Welcome to our very last lesson on functions. In our previous lessons, we looked at if you have a single input and you subject it to the function, it gives you a corresponding output. And then we proceeded to look at the situation where you have, let's say, a list or a set of values, and then you are given a function to find the codomain or the range. We looked at that. And then we look at certain operations on functions, definition of functions and all that. Now, in this video, we are going to look at, let's say, we give you certain expressions or certain functions, and then we ask you to perform certain tasks. So this is more like a question and answer kind of section, okay? So stay tuned, and I hope that you join me and you are ready to start. Okay, now let's say you are given this function, f of x is equal to ax plus b. Okay, f of x is equal to ax plus b. And then they go on to tell you where a and b are real numbers, so they can tell you are real numbers, belong to the set of real numbers. Then f of say 2, okay, f of 2 is going to be say 6, right? They gave you f of 2 is 6, and the situation where f of say 1 is 4. Okay, so they're giving you this situation that you have a function, and then the f of 2 is 6, and then f of 1 is 4. Very well. So when this is given to you, and then the question is asking you to find a and say b, find the values of what? A and b. So you have to find the value of a and b. This is not different from the normal ideas we have. With this one, the function is defined, but it's having some variables within it, making this function not to be fully complete. So what they are trying to ask us to do is to find those values, so that at the end of the day we'll get a real expression of what the function. So that is the exact task we are given in this aspect. So with this, what you need to do is to get the idea from here and then this. So it's the application of the very first lesson we had. Now, they are saying that with this function f of x, which we don't know the full expression, when you put 2 into this function, you are going to get 6. That is the meaning. And then when you put 1 into this function, you are going to get 4. So with these two preambles given to us, we should be able to use the idea that we generated from our very first lesson to be able to establish the function. Okay? So now let's see how we are going to solve this. So say the solution of this. Okay. Now, f of 2 is saying that when I put 2 into this function, I'm going to get 6. So basically, f of 2, which will be a, then in place of where x is, you are going to put 2 plus b. Okay, that is when I put 2 into this function. So you are going to get a, 2, then plus b. So anyway, I would say f of 2, it could be expressed as what? 2a plus b. So f of 2 is going to be 2a plus b. Then, if I have this expression here, per the preamble given to me, the value of f of 2 is actually 6. So we can also say then, therefore, this expression is also 6. Because you know principle of, we call it transitivity. If A is equal to B, and then B is equal to C, then in direct relation, we are just saying A is equal to C. So this is principle of transitivity. So if you want to use principle of transitivity, then if we say f of 2 is equal to this expression, and we know f of 2 being 6, then therefore this expression is going to be 6, the principle. Okay, so that we have 2a plus 2 plus b is going to be what? 6. Okay, then this is just one equation. This is just one equation, but the unknowns here are 2. So it tells you that we cannot solve this in one equation, 2 unknowns. It's not easily solvable. So we have to generate another equation. That is why they brought us a new and another preamble. That's why they brought another preamble. Okay. So with that preamble, let's do that one to side by side like this. So let's say we are working on this f of 1. So f of 1 means that we are putting 1 into the function. So it means that f of 1 is also going to be, wherever I see x here, I'll put 1. So that is going to be a plus b. And that will be a plus b. So this one here, the same principle of transitivity. Then we can say that okay, if f of 1 is giving us 4, then we can say a plus b in itself is also going to give us 4. Okay, a plus b in itself is going to give us 4. And that is what this is actually saying. Right. So it's more like we've generated 2 equations. This is equation 1, and then this is equation 2. And whenever you have 2 equations with 2 unknowns, then it's easier to now work that out. And 2 equations with 2 unknowns, then we have to borrow the idea from simultaneous equation to solve this. Okay. Now in simultaneous equation, you know we have 2 ideas: the substitution and then the elimination. But this one, substitution, we normally advise it for when the functions or the expressions in the equations given to you are not linear. Then we advise you to do the substitution. But when they are linear, then it's cheaper to go by elimination. But either ways, it will work. Okay. So now let's look at using this into 2 equations to find the value of a and b. So we are now borrowing the idea from simultaneous equation. So the very first equation, 2a plus b is equal to 6, equation 1, and then a plus b is equal to 4, that is equation 2. Okay, so if you want to use elimination method, then with the elimination method, we said that okay, we can either make the coefficient of a the same, or we can make coefficient of b the same. But this one, coefficient of b here is the same, because here is 1 and here is also 1. So since the coefficient of b are the same, we don't need to do so much. They are both positive, so if we want to eliminate, we can only do negative. So we subtract the second one from this. We'll do an upcoming video on algebraic expression, which will go in detail into how to do this and several examples. Good. So then 2a minus a is going to give me a. And then b minus b is 0. So there is no need writing that. And then when you go to the right hand side, 6 minus 4, and that is going to be 2. Okay. So then clearly with this we have gotten the value for a. We have the value for a now. And so knowing a, then it now becomes relatively easy. It becomes relatively easy because all I need to do is to put a in either this equation or the very first equation. Any of them, you get it. Okay. So we can say that okay, put a into say equation 2, because it will be easier working with equation 2. So you should put A into equation 2. So equation 2 is there. We are only putting the answer we had for A into that equation. So then this one is going to be 2. Wherever I see A, I'm going to put the value there. So this is going to be 2 plus B is equal to 4. Hence, when you group like this, my B is going to be 4 minus 2. B is going to be 4 minus 2. And so 4 minus 2 relatively, B is also going to be 2. So it is very, very important now to see that with this particular one here, just by passing through simultaneous equation, you can actually determine the value of A and B. So in a situation where you are given a function where there are some unknowns in there, a function where there are some unknowns, if you are lucky and this one was just a value, then only one image could produce the answer, only one image. Because if I put it inside and I equate it to this, the value of A will come. But this situation, we have two unknowns within the same function. So when that happens, then we need two images. The answer for two images to generate our two equations before we can determine the value for the unknowns within the given function. So that is how, this is also a question that can be given to you in any case. You can be asked to determine that. Are you okay? So you just have to quickly do this at your own pace and at your own discretion, and then you get back to this if you have any challenge. Anyway, this video was brought to you kind courtesy Mr. David Wakemi, Principal Proprietor of King David College. If you see and watch this video and you are enjoying, a word of prayer to him will be very, very much appreciative, because he's doing it for the good of all. Thank you very much. So let us proceed to another aspect of the question. Let's say you are given a new set of questions. For instance, let's say 2x plus 7. Okay, the function is 2x plus 7. And then they are asking you to find the image. Okay, find the image of, say, x plus 1 under the function. So you are finding the image of f plus 1, x plus 1 under the function. When you are giving things like this just looks like the composition of function we did, where x plus 1 in itself is also a function on its own. Just there is no name. Okay, so you can just treat this as a single value like A, just like you'll be treating a single value expression. So you can treat this one just like a single value expression. So in that aspect, the same idea of how to find image is what you do apply over here, the very same idea. So if you are asked to find the image of x plus 1, then it means that anywhere I find x, I'm just going to replace it by x plus 1 in my given function. Okay, so my f of x plus 1 is just going to be this expression, just that every x now will be replaced by x plus 1. Every x will be replaced by x plus 1. So all that will go into this is going to be 2 multiplied x plus 1 plus 7. And then all will be 2x plus 2 plus 7. And so your answer is going to be 2x plus 9. And that is all. So I believe, however the question is placed, whatever the question is just simple. With this tutorial and getting more questions to solve and all that, it's just going to help you have no challenge at all in functions. And so this is where we will end our whole lesson under functions. The numbers are displayed at the bottom of this video, and then you can watch it. Pick the numbers. The numbers, they lead us to you and to the administration of King David College. We will be ready to assist you with any issue you have. Okay. So until then, see you in our next lesson, which is going to be coordinate geometry. So see you over there. Bye bye.